Good evening. In the last videos, we are discussing some basics. How we can able to measure the time complexities. What are the different types of functions which are existed? We are discussing. In that, we have seen how to measure time complexity with constant time. What kind of algorithms will comes under this category? Similarly, linear time. Similarly, logarithmic time. Similarly, n log n time. Similarly, quadratic time. Similarly, exponential time. Similarly, factorial also. To demonstrate this, we have taken first example by taking a loop. So I defined a simple function to print the numbers from 0 to 100, just to generate a loop which will start from 0 to 100. So 100 times this loop is going to run, sir. That count variable I have inserted and to measure how many times it is working. So it is going to, this function is going to return that count value. Just I am printing. Why I am using this? Because to explain this algorithm is going to take big O of n time. Because if your n value is 100 times it is working, 100 times it is running. Okay. So to print the, Rakesh, what is that? No, can you please confirm? Right. So we have printed how many times it is working. That is nothing but 100 times this loop is going to run. So that part we discussed very clearly as a first example. Second example, nested loops part 1. That means a loop within another loop I am taking. I is equal to 0, I less than n. Inside this I am taking one more loop starting from j is equal to 0, j less than n, j plus plus. Here I am incrementing the counter. How many times outer loop is going to execute? Those many times inner loop is also executes, but there is no dependency. For every iteration of this outer loop, inner loop is having its own constraints. That's why there is no dependency. But first iteration, it will execute all the iterations. Second iteration, it will execute all the iterations. So in this case, how much time it is going to take? N square, because for a loop, so if the input is n times this loop will work. We have another independent loop is there. That's why, so it is also, it is starting from 0 up to n. That means n times. It is also starting from 0 up to n times. N into n square times this loop is going to run. That practically we displayed in the last video. Suppose if you are taking other example like nested loops part 2, sir, I have taken 3 loops. This loop is going to take n times. This loop is going to take n times. This loop is going to n times. Sir, don't take a plus here because so inside one loop, another loop is there. So n into n square into n cube times it is going to work. So even we have seen with the practical proof how it is going to work. Okay. So these are the 3 loops which we covered in the last video, just to demonstrate how we can able to measure these complexities. So up to this, I think it is very clear for you people, right? Please confirm everyone.
Yes, sir.
Clear, right? Right. Now, what I am going to do is I will take some other examples for demonstration purpose. Example number 4. So here I want to take one arithmetic sequence, sir, or I can say arithmetic series I am going to take. Okay. Let us see how it is going to work. I want to demonstrate by taking one arithmetic series. So how much time it is going to take, I want to measure. Okay. So I want to define a function which is going to take an input as n, and the count is equal to initially 0, I is equal to initially 0, while the value of I is less than n. So how many times this loop is going to run? N times. Again I am taking one more loop, sir, while your j value is less than I. Have you observed? There is a dependency. Count is equal to count plus 1 and j is equal to j plus 1, and after coming out from this I'm going to take I is equal to I plus 1. And at last, we are going to return the value of count. Sir, now I want to print when n is equal to 100. So the number of instructions or how many times it is going to execute is nothing but so big O of here also we can take n square. N square is it going to take or n it is going to take? Let us a cross check. Okay, let us a cross check how it is going to calculate. So how we can print? Just I am going to take function of n. Function of n. What is the n value here? Let it be 100. So first I want to demonstrate how this loop is going to execute, sir. Okay, how this loop is going to execute, we need to demonstrate now. Let us see how it is going to work now. Sir, first time when I is equal to 0, when I is equal to 0, how many times j is going to run? Sir, nothing, because 0 less than 0 condition is false. When I is equal to 1, how many times j is going to execute, sir? How many times j is going to execute? Have you observed? It will work for 0. That's all, only one time. Because since I value is 1, 0 less than 1 condition will be satisfied, but 1 less than 1 condition is not satisfied. When I is equal to 2, so your j value will become 0 and 1. When I is equal to 3, your j value will become 0, 1 and then 2. So that means I am writing in the arithmetic series. Okay, like first we are going to get 0, plus we are going to get 0. Okay, so plus we are going to get 0 plus 1. So plus we are going to get 0 plus 1 plus 2. Next we are going to get 0 plus 1 plus 2 plus something like this. Sir, this is nothing but something like arithmetic series. Okay, something like it is going to take arithmetic series. Okay, for every time it is going to generate 0 first time. Okay, next time it is going to generate 1. Next time it is going to run 2 times. Next time it is going to run for 3 times. Next time it is going to run for 4 times. Next time it is going to run for 5 times. Like if you are taking n value, then n times it is going to run. I think we can say n into n times it is going to run. Okay, sir, what will be the time complexity? Have you observed? It is something like so like this, right? N into n plus 1 by 2. So then how much value we are going to get? Approximately n square. It is also going to take time complexity approximately n square. Of course, divided by 2 is there, so that you can able to ignore, because the numerical values always dependent, right? Sometimes you may take 2 or sometimes 3. It is going to keep on changing. Okay, that's why we can ignore this, but output we are going to vary, but time complexity for this is nothing but n square. Why we are taking n square? This is the series. So first time this inner loop is going to execute 0 times. Next time this inner loop is going to execute 1 time. Next time this inner loop is going to execute 2 times. Next time this inner loop is going to execute 3 times, because based on the value of I. That's why. So how many times it is going to run at the ending? N, I mean for n value, n into n plus 1 by 2. Those many times it is going to run, sir. Okay, I think you people got clarity how it is going to work. Can you please confirm, is the outline of this particular function, is it clear for you people? Please confirm, everyone.
Hello.
Sir, it's based on n value, right?
Yes, sir, it is based on n value.
Yeah.
My first value, suppose n is 3, then
Hmm.
inner loop will be executed 3 times.
Yes,
It is based on that inner loop, right?
this inner loop is going to based on outer loop.
Okay.
Suppose if I is equal to 3, how many j values you are going to get? J will start from 0, j
Zero.
will start from 1, j will start from, I mean, up to 0 to 1, 2, like this it will get.
9 times.
Hmm.
9 times.
9
sir.
times, 3 times.
No, 3 times, not 9.
Means,
When I is equal to 3, I'm talking about single iteration, sir. Not n value. This is I value. I'm talking about I is equal to 3 means, sir, don't get confused. I is equal to 3 means So I'm not talking about I is equal to 0, I is equal to 1, I is equal to 2. I'm not talking about n value also. If you take a single iteration like I is equal to 3, so how many times this inner loop is going to execute? For j is equal to 0, j is equal to 1, j is equal to 2. Because j value is depending on the value of I. That's what I'm explaining. Okay.
Yes, sir.
Got it, everyone? Please confirm. Clear up to this?
Yes, sir.
Right. So now I can say the time complexity of this algorithm is almost n square, sir. Almost n square, but definitely it is going to change. The reason for that is nothing but it is going to depend on other factors also, right? Because divided by 2 plus 1 something, all these things are there. But if we execute exactly how many number of times it is going to run, we will capture. Okay, let us see how you can able to do this. So I am running the program py space test.py. As you can see how much time it is going to take. 4950 times it is going to take. 4950 times it is going to take. Okay, but approximately it varies depending on the number. That's why I am going to represent this one as n square, sir. This is nothing but what we have example number 4 here. Now I want to take example number 5.
Sir,
What is
I have a doubt.
yes?
Sir, you have passed the number 100, right? And it is
Hmm.
taking a time complexity of n square. So it
Hmm.
should be 100 of square, right?
That's what I am explaining, sir. If you remembered or not, the actual formula for this is nothing but n into n plus 1 by 2. Okay, so here we are going to get n square plus n by 2. But I'm approximately considering as n square because I'm representing in the form of big O. Actually, these components also there. According to that, it is going to reduce. But
Sir,
I'm talking at a top level n square.
hello, sir. So this
Yes.
the formula n plus 1 by 2, it has
Hmm.
come from AP series, sir.
Yes, that's what. This is AP series only, right?
Okay, okay, sir.
Right. Clear? The person who asked this doubt, can you please confirm? Is it clear now?
And the sir, that the time which is it's in the millisecond, right?
Sir, it is depends, sir. Sometimes we will measure seconds, nanoseconds, milliseconds. It is vary. Here we are not going to consider time, right?
Okay.
Yeah.
Sir, even though if I am going to take as n plus 1 divided by 2 and I am
Hmm.
putting the value as 100, so
Hmm.
it should come 50-50. I mean 5050.
Sir,
So this
Ketan sir, your doubt is clear, sir. I understood your point. But I am telling, if you have an algorithm like this, we are not going to consider each and every instruction. Approximate time complexity we are going to measure. So from this formula, approximate time complexity is nothing but a big O of n square. If you calculate perfectly, definitely it depending on this two. It is depending on this one, and it is depending on all these factors. I am not calculating in detail. Approximately it will be big O of n square. Just remember this, that's all. Okay, whenever we are taking recurrence relations, there you can see how it is going to be ignorable. Generally, theoretically, we are going to ignore this. Okay,
okay, sir.
got it? Yeah. Some students are asking, sir, in the Java, how much time it is going to take? I'm not calculating based on programming language. It depends. Okay, so we are calculating generally. If you write the same program in Java, same complexity will be there. Right. So next, sir, I'm going to take the next example. Example number 5. Sir, I want to double the iteration. Okay, so double the iteration variable. I need to double the iteration variable. If you double the iteration variable, then what will happen? I will take one example for you to understand. Double the iteration variable. Now listen carefully. Same program, count is equal to 0. I will start from I is equal to 1. Okay, I less than n. So I'm going to remove these all these things. I will take only one loop. I less than n, count is equal to count plus 1. count is equal to count plus 1. Sir, if you return for n is equal to 100, how many times it is going to run? Let us cross check. I think 99, something like this we are going to get. Approximately it is 100. Sir, I want to double this value. That means, so I is equal to, I am taking I into 2. That is the reason why I have shifted this I from 0 to 1. Now what will happen? Suppose if your n value is equal to 5, n value is equal to 5, I start from 1. Is 1 is less than 5? Yes, it will do the operation count. Now your I value will become I into 2. That means input size is almost double. Input size is almost double. That means 2. 2 less than 5. Yes, condition satisfied. Count will become 2. Next time your I value will be doubled. 2 into 4. Sir, 4. So it will become 4 less than 5. Condition satisfied, 3. So when I is equal to 5, sir, it's a double. 4 double is nothing but 8. Is it less than 5? No, not satisfied. Not satisfied. Okay. So it is going to fail. How many times it is going to run? 3 times. Have you observed when n is equal to 5, how many times it is running? 3. But if you take n is equal to 10, how many times it is going to run? 1, 1 into 2, 2. So 2 into 2, 4, 4 into 2, 8. So 8 into 2. Okay. 16, something like this. 1, 2, 3, 4. Sir, have you observed? For 5 times, it is running. For 5, it is running 3 times. But if you supply n is equal to 10, almost 4 times. Have you observed how much difference is there? Like if you are changing this value, almost the number of instructions which is executing is almost decreasing, sir. I can say this is nothing but log n time, sir. How you can say log n time? Here, have you observed it is keep on increasing, right? So I can say 2 power k, correct, right? 2 power k, the nth term what we are going to get is nothing but 2 power k approximately. Okay, so here k value is 0, here k value is 1, here k value is 2, something like that. Sir, now apply logarithm, log n. Okay, and here we are going to get log 2 power k. Assume this is base 2. Base 2 I applied. Then log, here you can take k is equal to, so log 2 base 2. So this will be cancelled and 1 you are going to get. So approximately this time complexity is nothing but I can say big O of log n time. So if you calculate the value of n log 5, if you take base 2, so maybe approximately we are going to get 3 or 3 point something. Similarly, log 10 base 2, if you take approximately it will be 4, something like that. It is going to calculate. Sir, I need to see practically how much time it is going to take. So let us take log n here.
Hello.
So yes.
Sir, where we get this calculation, sir? Log n equal to log.
No, I am applying this log here because n is equal to 2 power k, right? I applied log in both sides because we know it is keep on reducing. That's why. Yeah. So now let us run this code and see how it is going to work. Sir, have you observed if the input is 100, even you can't imagine it is working almost how many times, sir? 7 times. 7 times only the loop is going to run. Is it correct? Let me cross check, sir. So I am taking n is equal to 100. N is equal to 100. Sir, first time I value is 1. Okay, first time. So first time n I is equal to 1. So is 1 is less than 100? Yes. Next time I into 2. Sir, 1 into 2, it will become 2 less than 100. Sir, next time 2 into 2, 4 less than 100. Sir, next time 4 into 2, so which is nothing but 8. Sir, less than 100. Okay, next 8 into 2, 16, right? Less than 100. So next 16 into 2, 32, less than 100. Almost 1, 2, 3, 4, 5, 6. So 32 into 2, almost it is 64, is less than 100. 64 into 2, I think it is going to approximately 120 or something, 128 we are going to get. Is it less than 100? No. So approximately how many times it is going to run? 1, 2, 3, 4, 5, 6, 7 times it is going to run. Have you observed? Like that we can calculate. Okay, remember carefully, if the input size is keep on increasing with the power of 2, then it is going to take log n time complexity. So even if it is increasing with the power of 3, log n only, but base is going to change. According to that, we have to write the formula. Beyond that, nothing. That's why we have to always talk about global. So almost it is going to take log n time complexity. I think you people got very clear clarity how much time it is going to reduce when compared with the big O of n, big O of n square, big O of n cube. Can you please confirm, is this example is clear for you people? Akhil is asking one doubt. In general, can we consider the algorithm is big O of log n if the input size is keep on increasing? That depends, sir. We can't give directly, but we can say if the input size is increasing, so depending on the algorithm, it is going to be generated. Definitely some algorithms will take big O of log n. We will show you how when we are talking about searching and sorting, there I will take, sir, this loop is executing this many times. This loop is going to keep on increasing the powers. So if powers are keep on increasing, it will comes under this particular category. Like I will do investigate on those loops when we are discussing, then I will categorize. There you will get full-fledged clarity. But internally, how it is big O of log n, just I am taking a simple program to demonstrate that. I request everyone to please confirm. Is it clear up to this, friends? Please confirm.
Ye-
I request
yes, sir.
everyone. Please confirm. I request everyone to please respond. Clear up to this. Sir,
Yes, sir.
is the time
sir.
complexity affected by the system speed? Definitely, Rajat. Definitely. Suppose consider I am using 8 GB RAM. If you run this particular program, so in 12 GB RAM, very within fraction of seconds it will respond. If you run in 256 MB RAM, then almost it will take 5 to 10 minutes time. Definitely, right? System requirements also is very, very important factor. Clear, Rajat?
Yes, sir. Sir, can you give one more example for this login?
Yeah, definitely, sir. Next example is related to that one only.
Okay, sir.
So here the value of k is 7, right?
The value of C is 7,
K
correct?
is 7.
Yeah.
Okay.
Sir, same. Is it only power of 2? Sir, why mission models not run on 8 GB RAM mission? Mission models, maybe. Sir, I don't know about that, sir. Please ignore. 1 second, I will copy paste this. Yeah. So this is nothing but if you double the iteration, what will happen? Sir, can you please do the same example with some different approach? So can you halve the iteration? So half the iteration variable, can you please do half? But sir, half means how it is possible? Because if you start from 1, definitely half means almost you are going to get a 0. So don't do that. Better take I value is equal to n, largest value, until I greater than 0. Reverse loop I am taking. Now, can I take I /2? Yes. Now we will see how much time it is going to take. So here the input size which I am giving is 100. 100. So your I value is going to start from 100. So next I value will become 100 by 2. So that means what? 50. Next I value will become what? 25. Next I value will become what? 12. Next I value will become what? 6. Next I value will become what? 3. Next I value will become what? 1. Next I value will become 0. Sir, 1, 2, 3, 4, 5, 6, 7. Sir, do you remember when I am explaining logarithmic function, I told binary search is going to follow this particular time. Sir, how? If you have 100 elements are there, I will compare with middle element. If the element is available, search is successful. When search is successful, don't tell it is big O of 1, because with one iteration we got the result. This is best case, but we have to analyze worst case. So assume this element is not existed here. Then this is 0th element, this is 50th element, this is 99th element. What we will do? We will compare this element which you are going to search with this. Is it available in the left side or right side? We will decide. If it is in the left side, we will take only this measurement. This half we are not going to compare. That means, have you observed, is it the scenario or not? Remaining 50 elements, we are not going to compare. So here also we will calculate middle and we will compare with that. If it is available greater than this, that means we have to search only with these 25 elements. That means again it is reduced. Sir, again it will be reduced half. 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 Here we have to check. If your element is matched with this, result is success. If it is not matched with this, search is unsuccessful. Like that we can. This is worst case. So best case means here itself we will get the result. Average case means maybe here we are going to get. But we need to look for all the cases and we have to write. Okay, in this case also, in our example, it is going to take how many comparisons? 10 comparisons. Okay, if you increase keep on by doubling, or if you keep on decreasing with divided by 2, same complexity we are going to get. Sir, can you please show me with the proof? Yes, let me take. I'm going to run this one more time. As you can see, it is going to run for seven iterations. It is going to work. So I think how this half iteration and a double iteration are working, and you people got clarity about the big O of log n, sir. Can you please confirm, everyone, is the concept is clear for you people, friends? Please confirm.
Yes, sir.
Yes, sir.
Yes, I request everyone to please confirm.
Yes, sir.
Sir, these 5 to 6 examples, at least now you got some idea about complexity, right? When compared with the beginning programs, is it at least better now?
Yes, sir, it is
Well,
better.
yes, sir. Yes. Going forward, we will get more, right?
Yes, that's all. That is a simple formula. Right.
But it's look like very complex.
No,
sir.
no. This particular chapter alone, we will be like this. Next and after that, we are keep on continuing with our programming, because first chapter introduction, actually I plan to take this at the end. But in every topic, I'm going to talk about this log n, big O of 1, big O of n square, like that. There you people are going to get confused. What is that big O? To demonstrate that, I have to supply this much medicine in the beginning itself. So it is somewhat different test, but you have to digest. So once if the first chapter got completed, rest of the things will be very easy and very interesting. There, in every algorithm, we are going to represent these terminologies. There you won't fear. That's what I am trying to explain. Okay. Yeah, this
Okay.
is
Sir,
log
after this,
based.
which chapter? Sir, after this, which chapter you are going to take, sir?
Sir, after completion of this, we are going to give one half an hour class is there for one chapter, which is nothing but how to solve these algorithms, some basic. Then after that, we are going to see some algorithms and some sample codes also, around some 25 or 30 programs we are going to see. So after that, I'm going to plan for bit manipulations. So how to work with bitwise operators, and is there any advantage of those bitwise operators? Next, arrays, list. So next and after that, recursion, like that it will be continued. Strings, linked list, like that, searching and sorting. Okay.
Okay,
And
sir.
now,
Oh,
means,
thank you, sir.
as you mentioned in the first class, you are
Hmm.
not teaching like that. You are randomly choose the
Yeah,
topic,
yeah,
right?
that depends, sir. That depends.
Okay. And sir, which topic we are discussing now?
Now we are discussing at very introduction how you can able to measure the complexity of algorithm, analysis of algorithm we are discussing.
Okay, sir. Thank you.
Shantanu is asking, sir, we will calculate time complexity of all programs. No, we are not calculating. I will give time complexity for every algorithm. Matter of 1 minute, I will explain. Because this algorithm is going to take these many loops, so time complexity will be approximately like this. For every function, I am going to write here itself what will be the time complexity of this particular function, because every time again taking this code and extracting the data means difficult process. That's why at the top level, I am going to explain for each and every algorithm. Okay. Right. So let's go for one more example, sir. Example number 7. Sir, what about space complexity? Actually, space complexity we can ignore because Shantanu, you know very well, in high level programming languages, space is not at all a matter. Once if your program execution completed, automatically garbage collector is going to destroy all the spaces whatever you have allocated. That's why we can ignore space, but while writing the program itself, we will reduce the number of variables. Okay, so we can ignore this space complexity. Right. So next one, of course, we know about this one. Again, I am going to repeat with one small example. So just for your clarity purpose. Okay. Sir, if I have consecutive statements, then what will happen? The complexity. For example, to demonstrate this, I am taking a function n, count is equal to 0. Let us start from I is equal to 0, I less than n, I less than n. So do you know, here I am going to take one more loop. Okay, one more loop. So j is equal to, I am starting from 0. So while your j value is, I think here also I less than n, your j value is less than, your j value is less than n, then count is equal to count plus 1, and your j value will become j plus 1, and here also I value will become I plus 1. Sir, can anyone tell what is the time complexity of this particular loop? Can you please tell me what is the time complexity of this particular loop?
Order
N
of n
square.
square.
Good.
Order
Order
of n
of
square.
n square,
N
n
square.
square. Okay. So now what I'm doing here is, sorry. So what I'm doing here is, I'm taking one more loop. I'm starting one more loop. Again, I is equal to 0, while your I is less than n. While your I is less than n. So again, I am starting from k is equal to 0. So while your k value is less than n, so count is equal to, again I am repeating count plus 1. Then k is equal to k plus 1. So then here I am going to increase I is equal to I plus 1. Have you observed? This loop is main loop. So I loop. And this loop is also same looks like this. Sir, I request everyone after speaking, please go to mute state, because these are the sessions being recording. So it will make disturbance for others too. Okay. So this is one loop. Same loop I am repeating. So already we have seen what is the complexity for this loop, big O of n square. Definitely this particular algorithm is also going to take what, sir? Big O of n square only. So the total time complexity of this program will become big O of n square. So again plus big O of n square. Okay. So according to mathematical formula, sir, what we are going to tell? 2 into big O of n square. Remember carefully. So this time complexity is big O of n square only. Okay. So approximately we have to take. For example, here you can able to see. So the first time complexity is big O of n square. Then second loop time complexity is big O of n square. So 2 into big O of n square, almost we can ignore. We can ignore this particular constant, and the time complexity of this program is nothing but n square. Like that we can measure, because these two loops are independent of each other. That's why we are taking separately. Suppose if these two loops are inside this loop, means single complexity we are going to get. Now this entire function complexity, you can't measure 2 into big O of n square. We have to consider big O of n square only. Sir, if possible, try to reduce these loops into a single loop, that you can able to use for improving the complexity. But mathematical term wise, we are going to count this one as a big O of n square, big O of n square. 2 into big O of n square constants we will always ignore at the time of calculation. Okay. So the time complexity of this program is nothing but big O of n square only. But when you are executing, how much time we are going to get? So 100 into 100 means 10,000. 10,000 two times, so 20,000 we are going to get. Okay, like this we can measure. That means when a single program is having 10 different loops, independent loops, don't count all these things like 10 into big O of n, like that we can't consider. So you have to consider only that part, because no one is going to write a loop like this. So if any such type of situation is coming, we will take this as a one function, this as another function. Best example I'm explaining for you people. Consider I want to search for 2 elements in a array. Sir, I'm going to write a code for searching operation for the first element. I'm writing again one more code for searching for second. Have you observed these two are same concepts only, right? Why can't you bring into a single function and you can make a call to that function? That is best, right? So same scenario here also. This loop, whatever activity is doing, this loop is also doing same activity. Maybe the numbers are going to change, the instructions are going to change, but how many times these are running same complexity, right? So create a separate function, try to assign that work for that function so that your complexity will be same. But here also complexity is same. During execution it may impact, but we should not use such a type of terminologies in our future. We will write a separate programs. I think you people got very clear clarity about these consecutive statements. If you have, what will happen? Can you please confirm clear up to this, friends?
Then, sir, how will you reduce it to the single actually?
That's what I told, sir. We have to create a function to do this activity. This
Already
one
it
I'm
is in
going
the
to-
function, right?
You can write a function within another function, right?
So function inside the function.
This function inside the function, or you can make this function as outside and you can call inside this function. Example also I told, right? Suppose if I want to search for any element, so binary search function will be available in the outside. So for first element search operation, you can call binary search. For second element search operation, you can call binary search. We will calculate time complexity for that algorithm, not for this. This is something like test cases that you are running. Suppose if single program is taking 5 minutes time to execute, if you run 20 times, 20 into 5, that won't give a complexity. We will measure the complexity at a time. If you are running one time, how much time it is going to take? If you are repeating that 1,000 times and you are saying it is it is taking so much of time, means that is depending on your data. It is not algorithmic problem. Got it? Clear, sir? Who asked this doubt? I request everyone to please confirm clear up to this.
Yes, sir.
Right.
Yes, sir.
Right. So next one, what we have here is, sir, I will write some other loop here and we will measure complexity of that also. Okay, I'm going to take some other loop. Let me take example number 8. For this, try to copy paste output. Example number 8. Sir, here I'm going to write some other loop here. Okay, so first I will take, then we will give name for that. So consider I want to define a function. I want to define a function which is taking n, and count is equal to, as usual, initially 0, and my value of I is nothing but n. So from ending we are printing until your I value is greater than 0. So I'm taking j is equal to 0 until your j value is less than I. Until your j value is less than I, count is equal to, I am taking count plus 1. Then your j value become j plus 1 and your I value will become I by 2. At last I have to return the value of c. Just we will take one simple example and we will analyze how it is going to work. Let us take n is equal to something like 10 I am taking. So the initial value of I will become 10. The initial value of I will become 10. Then j is equal to 0. So j values, how many times it is running? J is equal to 0. Then is it less than 10? Yes, sir. Then 1. Is it less than 10? Yes. So next 2. Is it less than 10? Yes, sir. So 3 less than 10? Yes, sir. So 4 less than 10. 5 less than 10. So 6 less than 10. 7 less than 10. 8 less than 10. 9 less than 10. Up to this it will run. When I is equal to 10, this is nothing but what we have. So what will be your next n value, next I value? I by 2. That means almost half it is running. So then what will be the value of j? Have you observed the value of j is depending on the value of I? So how much time it is going to take? Sir, 0. So 1, 2, 3 and then 4, up to this it will come. Then when I is equal to, what will be the next I value? I by 2, that is nothing but a 5 by 2, which is nothing but a 2. Now what will be the value of j? I think it is going to run for 2 times, 0 and then 1. Then what will be the next I value? 2 by 2, which is nothing but 1. Then your j value will become only 0. Like this, if any situation occur, how much time it is going to take? How much time it is going to take? Sir, can you please confirm, anyone, how much time it is going to take, sir? Can you guess?
N log n.
Mhm.
Order of log n.
Order of?
Log n.
Yes, correct. It is going to take same previous example only, order of log n. So why? Because so this one is the main important factor, right? This one is the main important factor. Almost this loop is going to execute how many times? Almost half of the time it is reducing, right? Half of the time it is going to reduce. That's why how much time it is going to take? Order of log n. Is it correct? Let me cross check. So is there any change in the output? We are going to decide. Okay, so I think it is not order of login. So compulsory
N log n.
I think so n login will come, but this loop is going to keep on reducing. Okay, this one is login. Okay, but here it is going to run 10 times. It is going to reduce. It is going to reduce. It is also going to reduce. One minute, let me check.
So, sir, loop of j is also decreasing by the half. So I think so it is a login.
Hmm. It is also keep on reducing. One second, we will
Loop of j
execute
has repeated for 18 times.
197 times the loop is running. 197 the loop is running. So we have to measure this one mainly. We have to measure this one mainly. So this loop we know it is taking log n time. This loop we know log n time it is taking. So we can't say this one is n because it is it is not depending on n, right? That's why we can't say it is n, because if it is n, then definitely all these answers should be same. No, it is depending on the previous value. So here also it is keep on reducing. So I think this one also will comes with the log n only, because it is depending on other variable. So how much value of I is there? So based on that only this execution is depending. Okay. Yeah, some constant into log n. Yeah, that's what. Right. So this algorithm is also going to take how much time? Log n, some constant into log n, but we can ignore that constant value. I can say log n, sir. But here you can able to see there is a change in the output. 197 we are getting, but don't worry. If you keep on increasing the numbers, that definitely is going to change that value. That we can't give guarantee on the input size. Okay. So just now I have taken some example, right? So we can say this one time complexity is also big O of log n. Okay, clear up to this? Maybe some people are getting confusion. Don't worry. So it is almost same like previous program, sir. Clear up to this? Please confirm. Right. So can we try with multiplication? Is it going to give the same result? Can we try with multiplication? I is equal to 1. So I will take I less than n. Okay, j is equal to 0. j less than I, c is equal to c plus 1, j is equal to j plus 1. Can I take star here? Now we will see how much time it is going to take. Yeah, almost it is also same, sir. Yes. So it is going to take how much time complexity? Big O of big O of log n only, sir. Confirm. Big O of log n only. This is nothing but example number 9. Okay. This is the way how you can able to measure complexity by taking some simple loops. Last example I am going to take. Sir, I will explain multiple loops in big O of n time. Okay, multiple loops in big O of n time. This is our technique what we have to apply. Sir, if you see in the first examples, so when we are taking multiple loops, sir, automatically, what is the complexity? Almost it is double, right? If you supply n is equal to 100, we are going to get n square. We are going to get n square. But now my requirement is I want to use multiple loops only, but I need to reduce the complexity. How you are going to do? This is the technique which we are going to follow in our what you can call searching and sorting techniques. Sorry, sorting techniques. Let us see how I can able to reduce. I'm going to define a function. So count is equal to 0, I is equal to 0. I will represent j also 0 until your I value is less than n. So while I am taking j less than, okay, j less than n. So count is equal to count plus 1, j is equal to j plus 1, and I is equal to I plus 1. Sir, return C. Sir, have you observed here? Since I have initialized both the values at the outer loop itself, so when I is equal to 0, okay, so suppose, sorry, better to take n value. Suppose if n is equal to 3, what will be the value of I? 0. So what will be the value of j? 0. Okay. Sir, is 0 is less than 3? Yes. Is 0 is less than 3? Yes. Then both the conditions are satisfied. It is going to execute. Count is equal to count plus 1. Okay. So your count value will become 1. Next, j is equal to j plus 1. Next time your j value will become 1 and I is equal to I plus 1. Just by simply shifting that initialization to the beginning, sir, every time initialization is not going to be happen. Whatever previous j value is there, it will carry forward with that. Now, is it less than 3? Yes. Is it less than 3? Yes. So then it is going to count. Your count value will become 2. Sir, when I is equal to, next time I is equal to 2. Is it 2 is less than 3? Yes, sir. J is also 2, right? Is 2 is less than 3? Yes, sir. Then it will be incremented. So when I is equal to 3, 3 less than 3 condition not satisfied. If this condition is not satisfied, it is coming out from this loop. Now your I value will become no. It is going to terminate. Okay. So we are using nested loops, but this is the first time, this is the second time, this is the third time. That means when n is equal to 3, it is running only 3 times. That means if you supply n is equal to 100, it will execute 100 times. I can say the time complexity is nothing but a big O of n. But inside this, we have used how many loops? 2 loops. By changing the initialization, updation, we can get these kind of results. That we have to think while developing the logic and we have to write. Have you observed when n is equal to 100, how many times it is executing? 100 times only. Like that, we can write multiple loops. So to make, to reduce the time complexity to big O of n. So I think you people got very clear clarity about these things. Can you please confirm everyone, is the concept is clear for you people?
Yes, sir.
Right. So this is nothing but the first chapter. Okay, this is nothing but the first chapter. What we have, just some measurements we have done. Beyond that, nothing. First chapter, algorithms and analysis of those algorithms. Maybe some people has bored about this particular session, but you can ignore. And if you want to get more clarity, try to watch this first chapter videos minimum 2 times, because 3 classes we have taken on that. Then second chapter tomorrow we are going to start. It is nothing but approach to solve problems. So this is the problem with majority of the students. Sir, if I want to solve the problem, what kind of knowledge I have and how I can able to divide the problem, how we can able to solve, that we are going to discuss in the second chapter. It will be finished tomorrow only. Okay, a small chapter. Then I'm going to talk about the third chapter. In the third chapter we are going to discuss about some sample algorithms. Okay, sample algorithms and its implementations. So sample algorithms and implementations, we are going to see the different approaches. In these algorithms I am not going to measure any time and space complexities, because this is only for improving our fundamental skills. Okay, so I think we have around oh, this is not the program. I think we have around some 30 programs are there, 30 or 20 programs are there. We are going to discuss about this. One second, I will give that list also. Yeah, so we have these 30 programs are there, even or odd number, in how many ways we can calculate maximum, minimum, how you can calculate, what are the different approaches we have, swapping, absolute value, sum of n natural numbers, factorial, digits extraction, count how many digits are there, reverse of the number, palindrome, trailing zeros present in the factorial, iterative power, sum of digits, sum of even digits, sum of odd digits, sum of prime digit, prime numbers are not, prime factorization, all divisors, power of x to the 1, perfect number, Fibonacci sequence, Fibonacci sequence. These algorithms we are going to solve. Sir, you can say this is nothing but something like uh, uh, some basics related to the Python. In this, wherever some new concepts are coming, feel free to ask the doubts. I will explain in detail. Around some 3 to 4 days, we are going to talk about this. Okay, right, sir. So tomorrow we will meet for the continuation. Sir, it is a very small concept, sir. Around 20 minutes it will take. That's why tomorrow I will finish this second chapter and I will start the third chapter also in the tomorrow's session. Okay, right. I will upload these running notes.
So till now you haven't talked about data structures, sir. When you
No, sir.
when
No, sir. Directly at very beginning, we want to talk data structure, sir. We need to understand the basic fundamentals, right? So maybe in the, if I am talking about directly tree data structure, there if I am discussing time complexity of this insert operation is something like this, then definitely you are going to ask what is that big O of n. That's what we discussed now. Okay.
If you directly teach the data structure directly, then people will run
Definitely,
live this session,
definitely,
sir.
definitely. You
Because
can see
this
only
is this,
only 5 or 6 members we can expect in the class.
right, sir.
Yeah.
Sir, from next Tuesday we will start the continue the session, na?
No. Tomorrow class is there.
No. From next 2 days, you have said that all the demo lectures will be completed and we will start the actual course.
Sir, already we started actual course.
Okay.
Sir, this is the chapters in the data structures only. All these things, whatever we are discussing, it is the regular chapters.
Okay, sir.
So time complexities we discussed today, right? This is not a demo, sir. This is the regular classes, and all these programs also, it is a part of data structures only. So here you are going to learn the concepts, how you can implement in future. Suppose if any swapping of two numbers coming in the future, so we are going to see what are the possible ways are there to swap two numbers. Among that, which is the best that we have to put there. Are you getting my point?
Yes, sir.
So what is mean by algorithms, sir? We are going to see various what you can call various different methodologies to solve the problem. That's what we are discussing. Got it? Sir, I am requesting everyone, the syllabus already started. So we are at very beginning of these chapters. So you can expect pure data structures in the middle, but don't come to the middle of the class, because these are the basics, whatever I am providing now. So without this knowledge, Tomorrow, if you are asking anything about, sir, how this is big O of log n, can you please explain me, means I can't. So for that only I have given these 10 examples. Okay. And similarly, when I am doing, suppose in the algorithm, I'm going to write swap A comma B. So there, if you ask, sir, what is mean by swap, means I can't explain, because there we need to concentrate more on the problem in the data structure. Suppose if I want to insert a node into a tree, while inserting, we have to compare with each and every nodes, and whenever it is required, we have to do swap. There we are not going to discuss about swapping. Just I will write the code directly. That's what I am telling. Okay. No. As of now, no big book is required. So try to follow my videos, sir. Try to follow my lectures. It is more than sufficient. So I
Sir,
uploaded
one
the
of-
running notes. Please cross check, and you can practice the programs. Okay.
The running notes you have sent in the email ID which has been registered, right, sir?
No. You can, yeah, for that only I have shared. But if you want to see the running notes, just to open your Gmail and then go to your drive, and there check, there will be a folder with name shared with me.
Okay.
Open this. There you are going to get a folder with this name. With which name you can able to see this name.
Okay.
DSA P Python, DSA with Python batch 1 April 2023. Like that, there will be a folder. You make it as a bookmark, a star. Then
Okay.
you are going to see that folders here.
Okay, sir.
So every day I'm going to upload here only. So
Okay.
if any images are coming, I'm going to upload here. So topic wise, chapter wise, I'm going to upload. As of now, there is no images. In the upcoming classes, we will.
Okay. Sir, that is good. That is class tomorrow, right, sir?
Yeah, tomorrow class is there as
Okay,
well.
sir.
And sir, what about Saturday, Sunday?
No, sir. This Saturday and Sunday we don't have any class.
Okay, and sir, you are taking one more lecture on at 7 p.m. also on daily basis, right? So, is there any overlap between these two, or these two are totally different?
These two are totally different, sir. There you are going to get logics, how you can able to build the program. But here we are going to learn the theoretical concept and how to implement that. Completely different.
Sir, in the 7 p.m. batch, that's logic based programming, you will teach, means whatever the concept you taught in the while, means outer loop, inner loop, such kind of program will be covered in that LBC.
Yeah, definitely it will be there.
So
There we
means
are
so
going
that
to
we
see a problem and how to solve that problem. That's all. But here problems will be there, but in the form of a concept. So here problems will be there in the form of a concept. Like I want to insert the node in single linked list. I want to delete. You have to take that concept and you have to write the program from the beginning. But there a small subset problem will be there. So that problem we have to solve. Already inputs and outputs are given there. Just we have to map corresponding program. To improve our logical skills, you have to go for logic based programming course. And this is purely language related, sir. That's all. Okay. Yeah, right. Thank you, sir. We will meet for the continuation tomorrow. Okay. Right. Thank you, guys.
Thank you.